everyone. We are Team 13 presenting clock gear trains. My name is Maryel Gonzalez, and joining me are James Momperousse and Jonathan Perez. We will begin with the history of clocks. Now, unfortunately, the exact date for when clocks were first invented is yet to be determined. However, the first timekeeping device is thought to date back to 1800 BC in the form of a sundial. By 1400 BC, the water clock, and hourglass were developed as slightly more improved methods of timekeeping. These devices were developed in Egypt, where they quickly gained popularity and eventually spread to as far as Greece, Rome, several Arab countries, and even China. By the 14th century, the first mechanical clocks emerged and were mainly used by monks and monasteries as devices to signal their times for prayer. Although these types of clocks were far better devices than sundials and hourglasses, they were still very inaccurate. These clocks were often off by 30 minutes to as much as an hour. It goes without saying that many readjustments were performed throughout the day. Now, interestingly enough, monasteries in Italy as well as England still preserve these classic timepieces that date as far back as 1386 and 1389. Finally, by the 18th century, gear trains were implemented to improve the accuracy of these time devices. Now, allow me to present Jonathan as he goes over some basic horology terminology.
So for those that don't know, horology stands for the study of the measurement of time. And before we continue on, we're going to go over some basic terminology commonly used within the field. First, a wheel is considered a gear. Next is the arbor. An arbor is the axle of a wheel or gear that rotates, which you can see here, here, and here. Leaves are the gear's teeth. And the train is the interconnected system of gears and pinions, which you can see this pinion on top of this gear, and the meshing of this gear with this pinion, and the overall system in general. And now James is going to continue on with the gear trains.
The 13th century saw the beginning of mechanical clocks using a clock gear train to record the motion of time. The pieces which make up a clock gear train are the going train, the mainspring, wheel train, striking train, and the motion works. Consider the main gear train inside of a timepiece. The going train has the job of transmitting power from the mainspring to the rest of the system. The going train is comprised of a power source, wheel train, escapement, timing source, and also the motion works. The power source typically seen in timepieces is a mainspring, which is a coiled alloy that slowly unwinds, generating energy for the system to use. The length and elastic properties in the spring is what actually determines how much power it can store. Another important piece of the going train is the escapement. This component keeps control of the power released from the main spring while moderating the rotational speed of the escape wheel, as can be seen in the above image. Many clocks are also built with a striking train built alongside and separate from the going train. The objective of a striking train is to create an audible sound to signal the changing of the hour. Usually made up of a rack and snail design, the striking train signals a hammer to swing and strike a gong or a bell. And as you can see here, the actual snail design. Now we'll have Jonathan present to you the wheel train.
So the wheel train distributes power through a series of gears in the system. The wheel train is a subsystem of the going train that carries power from the main spring assembly's great wheel to the escapement wheel while dividing the number of turns the escapement wheel makes. It scales up the rotational speed of the mainspring from the stored mechanical energy. The gears in this train are the only ones under a load due to the torque of the mainspring, so the wheels are the only ones that become worn over time within the system. Next, I'll show you a visual representation of the wheel train. In this diagram, you can see the center wheel, third wheel, fourth wheel, and escape wheel. Take note that the escape wheel has a special configuration of the tooth profile to combat the escapement with the locking surface and impulse surface. and every wheel in the wheel train drives pinions. Here you can see the power flow through the blue arrows in this diagram. The power comes from the power source or main spring to the great wheel or main wheel. Then it flows to the center wheel, which is also connected with the MotionWorks train to drive the hands of the clock, which is shown here. Wheel 3 drives the pinion to the fourth wheel, here, and wheel 4 turns once per minute while driving the escapement, shown here. It also drives the second hand for clocks with the second hand subdial. Wheel 5 is the escapement wheel that is released by the escapement one tooth at a time through a pendulum or wheel balance. And in this configuration, we have a balance wheel, which, like previously stated, can be changed for a pendulum. The final wheel is always the escape wheel, and the gear ratio between this wheel and the balance wheel determines the length of the pendulum or size of the balance wheel. Next, I'll go over the MotionWorks. The MotionWorks are a set of gears used for displaying the 12-hour analog time format we are generally used to seeing on a clock or watch. The goal of MotionWorks train is to reduce the rotational speed of the center arbor and divide the hourly rotation by 12 to drive the hour and minute hands. This is done thanks to the envelope teeth profile of each set of gears. Here you can see the hour and minute hands driven on top of the center arbor. This hour hand is attached to a concentric tube around the center arbor, which makes the concentric hands on the clock. Since the gears are stacked, pinions are used to transfer motion between the gears. As you can see, here is the cannon pinion. It makes one revolution every hour with the center wheel and arbor. There is also a 3-to-1 gear ratio with the transfer wheel, which you can see right here. This turns the transfer pinion, which meshes with the hour wheel at a 4-to-1 ratio. Drives the pinion, and this is the hour wheel. This gives us the necessary 12-to-1 ratio needed for our 12-hour time format. Now, in order for us to set the time on the clock, a spring friction clutch mechanism is used to keep the cannon pinion up against the center wheel as if they were connected under normal conditions. Here. When the clutch is engaged, it allows the pinion to slip against the center wheel, enabling a time-setting feature. Next, James will go over some pros and cons.
Analyzing the parts and design of clock gear trains, it can be found that it has a few pros and also a few cons in its function. The main advantage of gear train configurations is that it is reliable. The fact that it only needs a spring to power the device makes it very efficient in how it uses energy. Unlike an electrical watch that needs to have its battery replaced often, the mainspring in a clock only needs to be wound up to generate power. Another advantage is that the gear configurations are environmentally safe, since they don't require the disposal of toxic batteries. However, gear trains also have a few disadvantages, one being that the wear and tear on the moving parts deteriorates the inside, which eventually needs to be repaired. And unfortunately, the repair costs often are expensive when it comes to fixing these type of gear configurations, not to mention the corrosion that the inner workings often face. Now we'll have Maryel explain the future work.
Today, the clock and watch industry is becoming more and more obsolete. With the invention of quartz watches, atomic watches, and other more accurate timepieces, mechanical clocks have become more of a collector's items or luxury fashion accessory. As portable technology improved, namely cellular phones, laptops, with time displays, people no longer feel the need to have clocks in their homes, nor have the inclination to wear wristwatches. Still, the clock and watch industry stand optimistic as they develop new power sources such as solar-powered or body heat-powered devices. As such, no great developments have been made for improving the precision or accuracy of clock gear train mechanisms in these old-fashioned timepieces. This concludes our presentation. Thank you for watching.